Start with indefinite integration now. So, what is indefinite integration? Yes, students, you have been through all the 11th physics. You have been through all the indefinite integration, formulas, theory, everything, and you have been through so many questions which make use of integration in 11th. Now, we study first, we'll have an understanding that what is indefinite integration, what does it stands for. Now, the most important thing is that indefinite integration can be seen from two aspects. One is actually what is the basic meaning of integration symbol. If you see, it is summation. It's during summation, for example, if you sum up 1 to 10 numbers like 1 plus 2 plus 3 plus 4 plus 5 till 10, then what do you actually get? Their sum. So the counter is of 1. After 1, the next number which you are supposed to add is 1 more than the previous one. Then when you add 3 to 2, it means with a counter of 1 it is going after it. You understand? 1, then 2, then 3, then 4, then 5, like that you are adding up. And till what you have to add? Till 10. So there is a formula for that and all that, those things. But suppose, if you want to calculate this much length or area rather, length you can do it so easily. But suppose if you want to calculate an area under a line and above a line across two lines, between two lines I mean, rather across. So between the two lines, below a curve and above a line. Suppose you want to calculate that. Now the best way is given by integration. How would you add up and find that area? So you will divide it into small, very thin columns. Rectangles. They would be of very, very small width. Now when I say very, very small, what do I mean? I mean infinitesimally small. Now what does infinitesimally stands for? Like the way infinite means very large. How much large? You think of a number, infinite is greater than that. You think of any number, it is greater than that. Similarly, infinitesimally small is a number, whatever number you can think of, it is smaller than that. So that is infinitesimally small. So with an infinitesimal is width of these rectangles. You will say, sir, how it is a rectangle? Here there is a line, here there is a line, here there is a line, but above there is a curve. So here I'll approximate the curve to a straight line when the width is very, very small, infinitesimally small. Oh, very interesting. You see, whenever you are talking of small, infinitesimally small, you think of a number, say what? 0.0001. Oh, it's smaller than that. It's 0.000001. So that's what I mean. So when you decrease the width of these rectangles very much, then in that case the above curve can be considered limited to a straight line. So that would be considered as a rectangle. So these rectangle areas we'll calculate and we'll add them all. So when we add them all, we actually get the integration of the function which you are calculating, that above curve. Okay, we are not going into the depth of it. In the chapter definite integration, we'll go into the depths of it. Okay, that how actually we are constructing those rectangles, how many rectangles we are constructing, in fact infinite rectangles we are constructing, and how to calculate area of individual rectangle, that we'll learn in definite integral. As of now, we consider that integration is a short symbol for summation. Here the counter is infinitesimally small. Like in summation, the counter is integral 1, 1 plus 2 plus 3 plus 4. Here integration, the counter is bx, small width, again small width, again small width, again small width, again small width. We keep on adding that. Okay? So that is what indefinite integration stands for. This is one concept of understanding. Here, I'd like to make a point that whenever you have, let's say, whenever you have integration of a function fx dx, let's say fx is a function, you are integrating it and you get another function out of it, that is gx plus c. We'll discuss about this, what is c, and we'll do a PhD on it, so don't worry. Now, this symbol stands for integral sign. Integral sign, that is what it is actually replacing the summation sign, okay? While this is the integrand, a simple basic terminology, students, I think this would go well with you. So this symbol, like an elongated S, if I am allowed to say that, that's a Greek symbol, integral sign. fx, the function whose integration you are doing, is known as an integrand. And this is the counter which you are doing, okay? The counter, that is with respect to x. With respect to x. So a lot of respects have been given to x here in this case. So with respect to in general is written as WRT, okay? So later on we'll use the symbol WRT. And what do we get here? We get gx, another function, which is the outcome of the integration. This is known as integral. Integral. Okay, students? Now, this is, for the time being, don't worry, I'll come back on it. It is an arbitrary constant. Sir, till now we have heard of constants. What is an arbitrary constant? Don't worry, dear. We'll work on it. Okay? So this is what integration symbol or integration of a function stands and their respective meaning of respective terms. Okay? This is one way of understanding it. And when we are understanding it in this manner, we, as you all students have done, integration of x. Yes or no? You have done integration of x is x squared by 2 plus c. Isn't that right? So this formula you have already done in physics plenty number of times. That is integration of x raised to power n with respect to x. What is that? X raised to power n plus 1 upon n plus 1 plus c. And what is not allowed here? Yes? N is not equal to minus 1. Oh sir, please come again. I didn't understand. Okay, no worries. The formula which I just spoke is x raised to power n dx is x raised to power n plus 1 upon n plus 1 and at additional c. Here n is not equal to minus 1. That is what? What will happen if n is equal to minus 1? Look at here. This will become 0. That will make it, yes, not defined or infinite. No, it's not infinite. It becomes not defined. Whenever you have an exact 0 in the denominator, that thing makes it undefined. Okay? So let's work on this. Now, that arbitrary constant can take any of the values. It can be 1, it can be 0, it can be minus 1, it can be minus 1333, and like that. Okay? So, we'll consider one by one. Let's say integration is a function. Suppose gx function we want to find the graph. We want to graph the integral function. So, this is the graph of, this is the integration of dx, x dx. This is, let's say this is considered as a function. So when you consider this as a function, it comes out as x squared by 2 plus c. And since you are considering this as a function, you take it as y. Am I right, students? Now, here I would consider this. Okay. So this is the function. This function actually I'm graphing out. So y is equal to integral of x dx, which is ultimately equal to x square by 2 plus c. So making a graph of this means making a graph of this. And since c is variable, I mean not a variable, it's a constant. But it can take any of the values like 1, I didn't say, 2 or minus 1 like that. Even you can take 0, either of those values. Let's see what happens when we take it 0. So when we take it 0, what actually do we get? We get the function as x square is equal to 2y. Now, from your knowledge of 11th class, coordinate geometry chapter, parabola, what sort of parabola this is? It's the upward parabola, isn't that right? So I'll just draw this parabola, draw this function. So this is x-axis, this is y-axis. Okay, I think this is quite clear. Isn't that? This xy axis is clear? Yeah. So here we first of all draw this curve. It's an upward parabola. So it would go like this. Okay, symmetric about x-axis. So this is the curve, y is equal to x square by 2. That is when we took that c as 0. Okay, when we took this c as 0. Then we take c as 1. So when we take c as 1, what do we get? We actually get 2y. Okay, 2 will be there. So 2y minus 1 is equal to x square. Correct only? This is the second curve. When we take c as 1, so when it is 1 I'll take it on the other left hand side, it will become y minus 1. Then I'll cross multiply 2, so it will become 2y minus 1. I hope you understand this. Pretty little bit of manipulation with the numbers. Now here, this parabola, how would you make? The vertex would be 0, where this becomes 0, that is 0, comma, where this guy becomes 0, that is 1. So the vertex is 0, 1, and the nature would be same as the upward parabola. So it would be this point. This is the vertex, and it would go like, sorry, badly shaped. Okay, again badly shaped. I think I should take some tutorials in drawing. What do you think, students? Now better? This one is the second graph. X square is equal to 2y minus 1. Okay, then we again take the next case. Let it be 2. Or rather minus 1, let's take. So when we take minus 1, the minus 1 will come on the left hand side, it will become y plus 1. So it will be 2y plus 1 is equal to x square. So what would be the vertex of this? I hope this is clear. So the vertex of this parabola would be 0, minus 1. So this is no sort of magic. It is where this becomes 0, where this guy becomes 0. That is 0 minus 1. So here I'll make it, this is the vertex, 0, minus 1, and this would be the curve. What happened? I think I made it nicely. So it seems tutorials are not required. Not very bad. So x square is equal to 2y plus 1. This is the third one which I've drawn. So here you notice that actually these all curves represent this integral x dx. Although we have taken different values of c, so since c we can take either of the values, any of the values, so there would be a family of curves. Don't you understand? That means this is what? A family of curves. Let me write it loud and clear. X dx is a family of curves. Why did I choose to use the word family? Because they show some similarity. Family, you know, suppose I'm Mohit Rastogi, my brother is Puneet Rastogi, another brother is Abhinav Rastogi, another brother is Vaibhav Rastogi, like that. So what is common in all of us? Rastogi. So there is something common. So what do these curves have in common? They are symmetric about y-axis. Isn't that right? So hence they would be called as family of curves, family of parabolas to be precise. Okay. So an integral considered as a function, if we graph it out, it represents family of curves. Okay. This is what I wanted to emphasize upon. I hope I could make my point clear. Now, thereafter, let's consider another meaning, another sense of integration, another explanation of understanding of integration. Okay, what's that? Now, look at this. What have we done? Integral of x dx is x squared by 2 plus c. Now, do one thing. You differentiate the function on the right hand side with respect to x. Here you are integrating with respect to x. Now here you differentiate with respect to x. Okay, dear students? Now we know whenever two functions are added or subtracted, the differentiation can be taken in the same way. That means we'll have d of x squared by 2 by dx plus dc by dx. Right? Now, x squared by 2, 1 by 2. So 1 by 2 is a constant, it will come out. What would be the derivative of x squared? This, I hope you can make it out. Derivative of x squared is 2x. Okay? What formula you are using? Derivative of x raised to power n. The formula is nx raised to power n minus 1. Come again. Shall I write it? Yes, why not, sir? That would be of help. Note. What note? Derivative of x raised to power n. That is x, oh sorry, nx raised to power n minus 1. Anything which is not acceptable in that, acceptable in this formula. What is that? What you are unable to what you are not accepting as a value of n. Tell me. None. Every value is okay with this. N can be a real number. Somebody said x raised to power e. How do you differentiate x raised to power e? That same exponential number e, that's what I'm referring to. Now, no matter it is an irrational number, it would be e x raised to power e minus 1. So no worries, you can apply this formula for any real number. And here constant derivative is 0. Correct only? So 2x and there was a half outside. So 2 and 2 cancels. What do you get? You get x. Oh, come on. Did you realize this x is the same integrand whom we were integrating? So that means integration can be understood as a reverse process of differentiation. We are talking about this now. Integration is the reverse process of differentiation. Means if you differentiate, you will actually get the integrand. So we can make note of this. Note 1, note 2. Integration is the reverse process of differentiation. Okay? Integration is a reverse process of differentiation. Don't worry, we'll start with the very finer details, basic concepts, reverse process of differentiation. Okay? We'll start from very low. Every student should come along, and thereafter we'll expand our knowledge, we'll expand our skills to up to any level. Okay? Third, now we go with the exact understanding of integration of the second type, that is integration as the reverse process of differentiation. We call it by another name, that is antiderivative. Integration, another name is antiderivative. Many a times you will have mentioned in the exam, rather than finding the integration of a function, you will have find the antiderivative of the function. So before you get confused, since you have seen Mohit Rastogi's video, you would be totally comfortable. So integration as antiderivative. So this I'll write with bold letters. Integration as antiderivative. Okay, so another name of integration goes as antiderivative. So you can very well understand that if differentiation of sin x is cos x, then integration of cos x is sin x. That's what we mean when we say reverse process of differentiation. I hope you understand. Now, by now we have discussed what integration means. What do we understand when we integrate a function? We are getting a family of curves, and those curves resemble in some way or the other, and if I have to specify that in what way do they resemble, or in what way do they constitute a family, that is that at a given abscissa x equal to x1, the tangent to all those family of curves will have the same slope. Repeat, sir. It is that the family of curves, if I draw an abscissa x equal to x1, I hope you understand. I'll exemplify here itself. Where was the diagram? If I'm here. And if you look at this diagram, and if I draw an abscissa, okay? An abscissa I am drawing. This is the abscissa. Let's say it is x equal to x1. Now, x equal to x1, I have drawn an abscissa. It is intersecting all the family of the curves at a certain point. So at one point it is intersecting, and here if you realize that wherever they are intersecting each member of the family, at that point if I draw a tangent, all the tangent will have the same slopes. Same slope means same inclination. Oh, slightly wrong. Every time I cannot make good diagrams every time, since I have yet to take tutorials in drawing. If any one of you is good at drawing, please do reach me and give me some drawing tutorials. Okay, just joking. Anyway, so you can see that all of these tangents have the same slope at this abscissa. So that is what is common in the family of the curves. So this is what we meant when we integrate a function. So we are talking about a family of curves. Then second thing which we understood is that integration is an antiderivative. That if differentiation of sin x is cos x, then integration of cos x is sin x. These two, having armed with these two concepts, Now the third thing which I want to emphasize upon is why an arbitrary constant c is introduced, why it is a requirement, why it is called an arbitrary constant, and in fact what is the meaning of arbitrary. That all we'll discuss now. Now tell me, integration is a reverse process of differentiation. Just now I quoted that derivative of sin x is cos x. Agreed? So cos x integration would be sin x. Am I right? So we write in the symbols used for integration, that would be sin x. That is, this implies this, so this implies that. But at the same time, if you realize that if I differentiate, rather I'll use a different color, that derivative of sin x, if I consider a constant here, let's say 4, and now if I differentiate, what do I get? Now I'll again get cos x, and the derivative of 4 is 0, so it is in addition, so no matter. Now if I go back to integration, that means cos x integration is, can you write sin x plus 4? No, you can't, because cos x, it can be, had it been sin x plus 5, then also you would have written the same thing, cos x. Sin x plus 15 also, the result would have been cos x. So you cannot write in reverse process that it is sin x with a constant 4. In fact, you will add up c. This would constitute either of the values of constant which would have been there at the first place. So had this been 4 or 5 or 6 or for that matter 7, 8, 6, any of the constants, this process would be true. So hence we see that we have to add c. Whenever we integrate, we have to add c here with the integral. Now whenever we have the that constant c with us, we call this as an arbitrary constant. Why? Actually, till now you have learned that there are constants, there are variables. Constant which are actually constant, they don't change. While variables are represented by letters of the English alphabet and their values keep changing. But there is something in between them, that is, although it's a constant, but it's a variable. Oh sir, what are you saying? It means that in a given question, it would act as a constant, but every time the question can be changed with changing those constants. For example, I quote a quadratic equation, ax square plus bx plus c is equal to 0. Now tell me what is the variable here? Obviously the variable is x. You are supposed to find the value of x. But what are ABC? Now ABC are arbitrary constant. For a given question, let's say a value is 4 and x will remain as a variable, b value is 2 and c value is 1. So that means in a given question you take down some value of ABC, some specified value is there, while the value of the variable you are supposed to find. So that means arbitrary constants are somewhere which are in between the variables and constants, because you can have another equation like 15x square minus 6x plus 2 is equal to 0. Now here these ABC values have changed, the values with 15, minus 6 and 2. So they are changing, yet they are constant. They are changing, yes, in different questions they are changing, but in a question itself they are a constant. So that's why the name arbitrary constant. I hope I could earn you a PhD over it. So I'll rub off this. This was just to mention and make you understand what is the meaning of arbitrary constant. Then, having done this, now we come to the simple integration techniques. But before we go on into the depth of integration techniques, we have to master simple integration. Okay? That means integration as the reverse process of differentiation. You will just have to imagine what is the derivative, what is the function whose derivative would be the question itself. Okay? Did you understand the usage of these words? What function will have the derivative whose integration you are doing? Okay? That's the way you have to guess. So please take out your notebooks because I'll be exemplifying with a lot of examples. So the ideal way would be that given an example, you pause the video there and you try the question yourself. Because what happens when you try the question yourself and then when you don't get and then you listen to the solution or observe the solution, then only you are actually gaining. Okay? And even if you have done it by yourself, then maybe I give you another way. And third, that even if I follow the same way what you have followed, it would be wise enough to do it because it would give you a double edge in remembering. So simple integration, you put the heading on. Okay. Now, simple integration, I'll give you some formulas, and based on those formulas, you will do these questions. Okay. Okay. The first formula which I would like to emphasize upon is the most fundamental one, and this you have done initially in your physics as well in 11th class. That is integration of x raised to power n. Okay? This is x raised to power n plus 1 upon n plus 1 plus c. So you will have to religiously put c with the integral. Okay? Now this formula is valid for every value except n is minus 1. So n is not equal to minus 1. That is what you cannot use. Okay? Now even if you don't have x and you have a linear in x. What's a linear in x? A linear in x is a polynomial which has the degree 1. Now degree 1 means the variable used is with degree 1 only. That's what a linear means. Like 2x plus 3, 5x minus 1, that's a linear in x. So I take a general linear in x, ax plus b. Again students, a and b are what? Arbitrary constants. So the integration would be ax plus b raised to power n plus 1 upon n plus 1 into the coefficient of x, that is a. And that again is not valid for n is equal to minus 1. N is not equal to minus 1. Okay? So here I am delivering this lecture from a cold place. So the weather conditions have instantly changed outside, giving me a lot of pleasure and hope and renewed interest into the lecture. So based on these two formulas, rather than 2, I'll write 1a. This is the same formula which we are referring. We'll do some questions based on these. We'll try out some questions. Number 1. Let's take up a question like integration of e raised to power ln of x. You will say, sir, you were talking about x raised to power and what you have brought just now. E raised to power ln of x. You didn't tell us anything about log or ln. You call this as ln. It's different from log. Why? Ln is to the base e, while log is to the base whatever is mentioned. So ln is to the base e. How would you do this? Now for this you should have a little knowledge of log, and according to it, if you have a raised to power log b to the base a. I'll give you a lecture on log separately. Okay, we'll discuss in detail logarithms, its laws, its rules, questions based on that, because it is very, very important for IIT. Mains and advanced both. Now, whenever you have this base and this base same, this comes out equal to b. You just have to remember this. That alone would suffice so far. Okay? Will you remember this formula? A raised to power log b to the base a is equal to b. So, what it means, when I have not mentioned the base here, didn't I say that the base is e? So here you have e, here you have e. So the result would be x itself. I hope you understand my point. Dx, and that would give instead, I'll apply this formula, n here is 1. So what you will have, 1 plus 1, 2 upon 1 plus 1. And of course a customary c. So that gives us x square by 2 plus c. I hope I could make my point clear. Then we go to the next question. Now I'll do a slight change and let's see whether you have understood the things or not. E raised to power, or maybe I can go with it. Just hold on. I'll change the question. Ln I'll take 1 upon e raised to power x. Oh my god, what I've done. So instead of giving you a variable here, I have given ln 1 upon e raised to power x. How would you handle it? Now we know 1 upon e raised to power x can be written in the numerator with its sign of the power changed to minus. So we can write it ln e raised to power minus x. Correct only? Now I'll teach you one more rule and of log. Already you might be aware of that, but it's worth revising. You have log to the base of to any valid base. The base validation is greater than 0 and it cannot be equal to 1. We'll discuss details when we'll be doing the chapter functions, as well as also when we'll be doing the chapter log. So consider any base, let me put k, and you have a raised to power b. Okay, so the log term is a raised to power b. So this is known as the power rule. The power of the term whose log you are taking will go out and get multiplied. It will become log a to the base k, and b will get multiplied to the log term. That's what the rule is. This is known as power rule. So we'll make sure that you make it as a, you convert it into a note. So I hope this is okay. Yeah, slightly displaced. Okay. So having done this, if we continue with our question, what do we get? Ln e raised to power minus x. What should be done? Minus x is the power of the term whose log you are taking. So minus x will go out and it will become, obviously not out of the integral sign, minus x ln e. And by the way, what did I tell you? Ln is base of what? It is e itself. So ln e to the base e is 1. So minus x is what you have to integrate. Minus is of no consequence. You just put it outside the integral sign. So you get minus integral x dx, and that's become the same question what we did earlier. It would be minus x 1 plus 1. We are following the same formula plus c, or in other words, that is minus x squared by 2. So that's the answer. Okay. So here we have completed 2 questions on simple integration. We'll go further. So the next question is third. This third question is basically you have to remember it. The result you have to remember. 1 by 2 root x. Okay. Before you start converting it into a fractional power here, x is to the power half. Under root of x is basically x is to the power half. You take it in the numerator, it becomes x is to the power minus half. And then you apply the same formula which you have been taught. But rather than that, my straight question to you is, which function derivative is 1 by 2 root x? And it has been taught to you very nicely. Here, I would like to emphasize upon which function derivative is 1 by 2 root x. Now don't tell me that you haven't done this before. You have done it. Which function derivative is 1 by 2 root x? Come on, come with me. The derivative of the function root x itself is 1 by 2 root x. So derivative of root x is 1 by 2 root x. I hope I could make you remember this. Okay. So in the same way, the integral of 1 by 2 root x would be root x. Of course, the process used is the same, x is to the power n. So if you want to follow that, you can do the same. You will write 1 by 2 x is to the power half, then it will go above. 1 by 2 will go out of the integral sign. It will become x is to the power minus half. Minus half integration is nothing but half into x is to the power minus half plus 1 upon minus half plus 1. Am I right? So minus half plus 1 is half itself. So this half and this half cancels. Minus half plus 1 is half. So the answer which you get is x is to the power half plus c. X is to the power half, how do you write it? You write it as root x. So you get the same result. So the process is same, but why I wanted to emphasize upon is that root x derivative is forcefully made you remember. You are made to remember the result of derivative of root x. That is 1 by 2 root x. So similar way, I can ask you to remember the integral of 1 by 2 root x, that is root x. Okay? Then we move on to the next question. Fourth, that is 2 raised to power, not 2 raised to power, sorry, let it be, okay, 2 only. Let us take this question. 2 raised to power ln x. How do you handle this? Ln x, again, the base is e. Okay? How do you do this? Now, 2 is not a variable. You cannot apply 2 raised to power ln x plus 1 upon ln x plus 1. That would be wrong. Here, whenever it's a real number, then only you can apply that, provided this is x or a linear in x. So it is neither. So here again, I'll teach you some logarithmic formula. Whenever you have a raised to power log c to the base b, then these two values are interchangeable. Okay? C you can bring down here and A you can bring down here without changing the value of the log. C log A to the base P. I hope this is visible to you. I hope this is visible to you. So here with the same change, by the way, I'll put it in a box so that it becomes a note for you. Okay, so here you have to interchange x and 2. So you can write x ln of 2. Now ln of 2 is a constant. It can be treated as n, x is to power n. So the integration would be x is to power ln 2 plus 1 upon ln 2 plus 1 plus c. You might not find this answer exactly matching with either of the choices given in the question. You may get in this form. X, you will write ln 2, ln 1, this 1 can be written as ln e. Similarly here, ln 2 plus ln e. And obviously a plus c. Now, I hope you know that terms in log to the same base, if they are in addition, it goes into product. I mean the inside thing goes into product. So you have x ln 2e upon ln 2e. This might match with one of the answers, okay, or this may be written. Once again, 2e can be interchanged with x. You'll write 2e raised to power ln x upon ln 2e. So either of the answers can be there. It depends which one is given. So you should understand which law did I use here? Power rule. So you have log of a to the base k, log of b to the base k is equal to log ab to the base k. This is the formula. I hope I made my point clear. So simple integration has now finished with the first part. I mean the first formula we have discussed. We'll go on with the second formula, and the trigonometry simple functions will come under this range only. In NCERT you have first exercise, that is 7.1 exercise based on this only.